Today we're going to talk about trig identities and equivalent expressions. First we're going to start off with trig identities. Now the first two columns there you should already know by heart, the reciprocal identities and the quotient identities. It's the third column that should be brand new to you. There are three identities. The first one is sine squared of theta plus cosine squared of theta equals 1. That's basically your main identity. And then the other two are 1 plus tangent squared of theta equals secant squared of theta. And then 1 plus cotangent squared of theta equals cosecant of theta. The two below the top one are just manipulations of the top one by trying to get sine squared of theta by itself or cosine squared of theta by itself. You're going to need to memorize these because they're used an awful lot. Like if in an equation they give you sine squared of theta plus cosine squared of theta, you're going to need to know that equals 1. Or if they give you secant squared of theta, you're going to need to know that equals 1 plus tangent squared of theta. So you're going to need to know how to manipulate these identities. So we're going to work on a couple of problems to learn how to manipulate the identities. Basically, the very top one can also give you the two on the bottom. So let's go through a couple and see what I mean. Using sine squared of theta plus cosine squared of theta equals 1. What does then sine squared of theta equal? So I want sine squared of theta by itself. In order to get sine squared of theta by itself in that equation, I'm going to actually subtract a cosine squared of theta on both sides. So I'll end up with sine squared of theta equals 1 minus cosine squared of theta. So again, I actually took an identity to manipulate it to make it look another way. All right, let's do a little bit more. Using sine squared of theta plus cosine squared of theta equals 1, what does cosine squared of theta equal? Well, it has cosine squared of theta in it, so to get it by itself, I'm going to, you're right, subtract sine squared of theta on both sides. So I'll end up with cosine squared of theta equals 1 minus sine squared of theta. Okay, let's take a look at number 3. Using sine squared of theta plus cosine squared of theta equals 1, what does secant squared of theta equal? Well, I don't have a secant squared of theta in this equation. So I have to think, what is secant? Well, if you can remember, secant is 1 over cosine. I do have a 1 in that equation. So if I divide that 1 by cosine, and in this case we want a secant squared of theta, so we're going to go cosine squared of theta, that will definitely give me my secant squared of theta. But again, we're doing algebra, so the rule is whatever you do to one side of an equation, you have to do to the other, which means I'm going to have to divide every term on the left by cosine squared of theta. In doing that, sine squared of theta divided by cosine squared of theta is tangent squared of theta, plus cosine squared of theta divided by cosine squared of theta is 1. So tangent squared of theta plus 1 is secant squared of theta. So that's another identity. So I use that very top identity to actually get one of the other ones. All right, let's do one more. Sine squared of theta plus cosine squared of theta equals 1. How can we get it to equal cosecant squared of theta? Well, cosecant is 1 over sine. I do have a 1. I can divide that by, in this case, sine squared of theta, because I need a cosecant squared of theta, and I'll get my cosecant squared of theta. But again, like I said before, we're doing algebra, so whatever we do to one side, we have to do to the other. So we're going to divide every term on the left by sine squared of theta. Let's see what we get. Sine squared of theta divided by sine squared of theta is 1, plus cosine squared of theta divided by sine squared of theta is cotangent squared of theta. So that's another identity. So again, if you memorize the very top identity, you really could use that top identity and manipulate it a lot of different ways to get all the other identities. All right, let's go on to equivalent expressions. Using identities to rewrite trig expressions. So if we can use an identity to rewrite it, they want us to do so. What do I mean? Well, for example, number 5, tangent squared of theta plus 1 is a trig identity. That actually equals secant squared of theta. But if I didn't memorize my identities, I would have never been able to do that. Another thing is, if it's not an identity, they want you to rewrite everything in terms of sine and cosine. Because then you can actually maybe do some canceling, and once you see what you have left over, if it can be rewritten another way, then you do so. For example, let's take a look at number 6. Tangent of theta times cosine of theta times cosecant squared of theta. It's not an identity, so how can I rewrite this? Well, tangent is actually sine of theta over cosine of theta. And since we have fractions, cosine of theta I'll put over 1 times, cosecant is 1 over sine of theta. It's a fraction times a fraction times a fraction, so I can cross-reduce. Everything canceled out, so my final answer is 1. So again, by rewriting it in terms of sine and cosine, I can actually reduce or simplify my expression. All right, let's do a few more. Secant of theta times 1 minus sine squared of theta. Well, 1 minus sine squared of theta is a Pythagorean identity. So right now I'll have secant of theta times cosine squared of theta, because 1 minus sine squared of theta is cosine squared of theta. Secant can be rewritten as 1 over cosine of theta times cosine squared of theta, and I'll put that one over 1. I can cross-reduce 1 cosine for 1 cosine, so I'll cancel out the squaring, and I'll end up with just plain old cosine of theta. All right, let's take a look at number 8. Sine squared of theta over tangent squared of theta. Well, sine squared of theta is just sine of theta times sine of theta. I don't think they want us to write it as an identity because it doesn't have a minus 1. And tangent is, I can rewrite tangent. So let's see what I have here. I'll have sine squared of theta over tangent is sine over cosine. Now I have a complex fraction. So I can multiply top and bottom by cosine of theta. The cosines on the bottom will cancel out. And on the top I'll have sine squared of theta times cosine of theta over sine of theta. I can cancel out 1 sine for 1 sine of theta, and I'll end up with sine of theta times cosine of theta. And I'm done. Okay, let's go on to 2 more problems. Tangent of theta times cotangent of theta plus tangent of theta. Well, I don't have a Pythagorean identity there. And I have tangent and cotangent. They're not in terms of sine and cosine, so let's rewrite those. I'll have tangent is sine of theta over cosine of theta. And cotangent is cosine of theta over sine of theta plus sine of theta over cosine of theta. All right. I can do distributive property, and I would get sine of theta over cosine of theta over cosine of theta times sine of theta plus sine of theta times sine of theta, sine squared of theta over cosine of theta times is cosine squared of theta. Sine of theta times cosine of theta and cosine of theta times sine of theta cancels each other out. So that's actually 1. Plus sine squared of theta over cosine squared of theta, is tangent squared of theta. And that's an identity. 1 plus tangent squared of theta is secant squared of theta. Wow, that was a long one. So what did I do? I got everything down, or what did I do? I got everything down to sine in terms of sine and cosine. I distributive property, and I was able to then cancel everybody out here and get a 1. And then sine squared of theta over cosine is another name for tangent squared of theta. And with the 1 plus, I knew I had an identity, so it's secant squared of theta. All right, let's do number 10, our last one today. Cosine of A plus sine squared of A over cosine of A. All right, I don't have any multiplying going on here. I don't have any identities. I have a fraction times a whole number, so I'm going to make cosine of a fraction by putting it over 1. I'm going to find a common denominator for 1 in cosine of a, and that's going to have to be cosine of a. So this fraction is not going to change at all. This is going to become cosine squared of a. So I'm going to bring over the denominator, which is cosine of a. Combine like terms on the top, which I have none, so I'm just going to have cosine squared of a plus sine squared of a. Ooh, cosine squared of a plus sine squared of a is a Pythagorean identity, which equals 1 over cosine of a. And 1 over cosine of a is secant of a. Wow, that was a big one too. So again, basically what we're doing is we're actually factoring and canceling as much as we can, or renaming it using sine and cosine or tangent or cotangent in order to reduce or simplify our expression. If you're really not sure how to do this, try a couple more again. Cover up your paper, try it again, see if you get the hang of it. If you still are having problems, bring those questions to class tomorrow. See you then.